Hello friends. Now, if seeing this problem on your screen you have no idea what to do, then today's lecture is for you. Now, if seeing this problem you kind of have an idea of what to do, then you should still stick around. But if seeing this problem on your screen and you are like, what the heck is that? Then today's lecture is definitely for you. No questions asked. Now, in working through problems in mathematics, there are some questions you must ask yourself. The very first of them would be, from whence cometh this question, right? Bible language, right? How true, how true. Now, you must ask yourself, where does this question come from, right? And how do I go about resolving it? In answering the first question, this problem comes from the topic indices. Now, what is indices and what is it all about? Let me take this problem off the screen and we'll come back to it when the concept of indices has been clearly understood. Now, indices would be the plural form of index. Indices would be the plural form of index. The index of a number, it dictates how many times we can use this number in multiplication. The index of a number dictates how many times we can use this number in multiplication. How true, how true. Now, indices gives us means by which we can represent algebraic expressions in a short form. Indices gives us a means by which you can represent algebraic expressions in a short form. For example, we could be given A multiplied by A multiplied by A multiplied by A multiplied by A. Now, we can represent this algebraic expression in a short form. We have to count the A's: 1, 2, 3, 4, 5, and this gives us, there are 5 A's, right? Now, what we do now is we pick one of the bases, one of the A's, that will be A, then we put 5. We put 5 as the power because there are 5 A's. So this will give us A raised to power 5. How true, how true. Also, if we are given A raised to power X now, A raised to power X, it's worthy of note to let you know that this would be called the base, and this would be called the index. It will be called the index. It is also called the power or the exponent, right? Also called the power or the exponent. How true, very true. Now, in understanding the concept of indices, right, we must first and foremost be acquainted with the laws of indices. We must be acquainted with the laws of indices. What are the laws of indices? The very first of these laws would be the product law. And in the product law, we could be given A raised to power X, A raised to power X multiplied by A raised to power Y, A raised to power X multiplied by A raised to power Y. Now, what happens now is that we pick just one of the bases. You notice that the bases are similar, right? So we have A's on both sides. So this gives us A raised to power X, and we add up the powers. So X plus Y. We pick one of the bases and we add up the. We could be giving questions to the extent of 2 raised to power 3, 2 raised to power 3 multiplied by 2 raised to power 2, 2 raised to power 3 multiplied by 2 raised to power 2. So following this product law, we pick one of the bases, right? So we pick one of the 2's. This gives us 2 and we add up the powers. So this gives us 3 plus 2, right? So this gives us 2 raised to power 3 plus 2. And in the aftermath, we have 2 raised to power 5 and your guess is as good as mine, guys. So we have to find 2 raised to power 5, right? So that would be 2 times 2 gives us 4, 2 times 4 gives us what? 8. 2 times 8 now will give us 16, and 2 times 16 will give us 32. So that is 2 raised to power 5 being 32. How true, how true. Now, the second law would be the division law. The second law is the division law. Now, how do we handle this whole piece? We could be given a raised to power x divided by a raised to power y. This gives us, we pick one of the bases like we did in the product law. We pick one of the bases, and since it says a raised to power x divided by a raised to power y, we subtract the powers. This is what the division law would be. So when you see two variables having the same basis and different powers, and they are one of them is dividing the other, what you do, you pick one of those variables, just as we have here. We've picked a and we subtract the powers. For instance, we could be given 3 raised to power 7, 3 raised to power 7 raised to power 7 raised to power 7 divided by 3 raised to power 5, 3 raised to power 5. What we do, like we just said, is that we'll pick one of the trees, right? This gives us 3, and we subtract the powers. Raised to power 7 minus 5, 7 minus 5, and in the end this gives us 3 raised to power 2, and 3 raised to power 2 gives us 9. The next law, how true, is called the bracket law. The bracket law. What is the bracket law? What is the bracket law? Now, we could be given things to the extent of a raised to power x. This would be enclosed in a bracket, and the power would be given raised to power y. So how do we handle this whole piece? According to the bracket law, right? According to the bracket law, what we do here in these sorts of forms is that we have a raised to power x times y. This becomes a raised to power x times y. How true, very true. So, for example, we can be given 2 raised to power 3, right? 2 raised to power 3. We enclose that in the bracket and we have raised to power 2. Now, what this becomes in the end would be 2 raised to power 3 times 2. Please, this should not be mistaken for the product law. In the product law, we add the powers, but here we multiply the powers, right? How true, very true. So this gives us 2 raised to power 3 times 2 right here gives us 6. 2 raised to power 6. So what we have would be 2 raised to power 6 would be 64. 64. So that gives us 64. 64. How true, very true, very true. The next law would be called the zero law or the zero index. Now, in this law, we could be given a raised to power 0, a raised to power 0, and by now it has been proven that any number raised to power 0 would give you 1. A raised to power 0 would give you 1. So if you have 1, 2, 3, 4, 5, no matter the value, raised to power 0 would give you 1. So I humorously tell my students, right? I said, if your bank account is within 1 million raised to power 0, it means that in the end you have just $1 in your bank account. How true, how true. Now, the next law would be the negative index law. The negative index law. Now, this law would help us to understand how we can go about having negative powers. Negative powers. For example, we are given here a raised to power negative x, a raised to power negative x. How do we handle this whole piece? How do we handle this whole piece? Now, according to the laws of indices, this becomes now your negative sign at your power always causes your value to be in the reciprocal form. Now what we have now is that we take the reciprocal. This becomes 1 over a raised to power x. That is what we have in this form. 1 over a raised to power x. What happens is that to eliminate the negative sign, this negative sign right here, we had to take the reciprocal of this. In playing with one of two classic examples here, we have that 5 raised to power minus 2. 5 raised to power minus 2. So in the end, this gives us, we said we were going to take the reciprocal of this value to eliminate this negative sign at our power, right? So this gives us 1 divided by 5 square. 1 divided by 5 square. So what we have is 1 divided by, now 5 square right there gives us 25. So 1 divided by 25, and this right here would be your answer. The sixth law would be the fractional index, or the fractional power. We could be given a raised to power 1 over x, a raised to power 1 over x, and this becomes, in explaining this for you, let me just highlight one or two things here. Now notice that at your power you have a fraction right there, 1 over x at the power, right? So the numerator becomes your power or index in what we are going to do now, and the denominator becomes your root. So this gives us the x root of a. This gives us the x root of a. That is what we have. That is what we're going to have. So your denominator becomes your root. How true, how true. In evaluating some examples, we have 49 raised to power 1 over 2. 49 raised to power 1 over 2. And in the aftermath, right, we are going to have that this 2 right here becomes our root. So this becomes the square root of 49. This becomes the square root of 49. And you know as well as I do that the square root of 49 gives us 7. How true, how true, very true. Gives us 7. Now, this fractional powers or fractional index has a second form in which it presents itself, right? That is the second form in which it presents itself. Now it could be given as a raised to power y all over x, a raised to power y all over x. Now what we would have here would be pretty much the same thing as we had in this one, right? A raised to power 1 over x. But in this case, now your y becomes your power. Your y becomes your power or your index, and your x still remains your root. So the rule is trying to say that whatever value you have at your numerator becomes your power, and whatever value you have at your denominator becomes your root. Now this gives us the x root of a, right, raised to power y. So what happens here is that our denominator became our root, right, and our numerator became our power. Let's play with one or two classic examples and see how it goes. So this gives us 8 raised to power 2 over 3, right? 8 raised to power 2 over 3. And from our law, we said that the denominator becomes our root. So this gives us the third root of 8. That's what it gives us. Now, raised to power 2 raised to power 2. How true? The third root of 8 raised to power 2. So in the end, the third root of 8 is 2. The third root of 8 is 2, because 2 times 2 times 2 gives us 8. Now, do not forget your square at your power. So this gives us 2 square. So in the aftermath, this gives us 2 square, giving us 4. How true? Now, the next law we're going to be talking about would be the negative fractional index. How does this whole piece come about? So we are going to have a fraction at the power, right? A fraction at the power. But the difference between this and the previous one was that this fraction has a negative sign. So what we have here would be equal to, now remember from our negative index law, whenever we see a negative sign at our power, we take the reciprocal, right? So this gives us 1 over a raised to power y over x. So because of the negative sign, we had to take the reciprocal, right, in order to eliminate the negative sign from our value. But don't forget now that this y over x at the power here still means something, and we can still evaluate that as something. Remember the previous law we spoke about, we said the x, right, at the denominator becomes your root, and your y at the numerator becomes your power. So this gives us, in the aftermath, 1 over the x root, write that x properly, the x root of a raised to power y, the x root of a raised to power y. So that's what we have in the aftermath, right? So let me take one or two examples. We could be given 27 raised to power negative 2 over 3, negative 2 over 3. So how do we handle this whole piece? So this gives us 1 all over, remember we said we take the reciprocal, right, because of the negative sign. So all over the third root, the denominator here becomes our root. So the third root of 27 raised to power 2. Now the third root of 27 at the denominator there gives us 3, because it's 3 times 3 times 3 that gives us 27. So this gives us 3, right? 3. So this gives us 3 square. Now 3 square, right? So 3 square gives us 9. So in the aftermath, we are left with 1 over 9. That is what we have in the aftermath. That's what we have. Now, the last law I will be dealing with, the last law I will be dealing with would be index with different bases. Index with different bases. Index with different bases. Now, index with different bases. How do we illustrate that? We could be given A multiplied by B, right? A multiplied by B raised to power X. A multiplied by B raised to power X. And in the end, this gives us A raised to power X, right, multiplied by B raised to power X. What happens in this case is that this X will be distributed across both A and B. So we have A raised to power X multiplied by B raised to power X. For example, if we are given 2 times 5 raised to power 2, so this gives us 2 square times 5 square. We distribute the power across both 2 and 5. So 2 square gives us 4. 2 square gives us 4, and 5 square gives us 25. So 5 square gives us 25. So in the end, our answer becomes 4 times 25, giving us 100. 4 times 25 giving us 100. How true, how true. That's my time, guys. In this video, we've been able to explain the laws of indices, right? Why don't you click on the next video? Right there, we'll be solving the question that was displayed at the beginning of this video, right? And we'll be playing with more worked examples. Thank you so very much for watching. Why don't you give us a like? Please do subscribe and ring the notification bell to get more of our content. Remember, knowledge will change your life forever. How true. Thank you so much for watching. See you in the next video.